The broadcast is now starting. All attendees are in listen-only mode.
Good morning. I am Faith Younghands, and I'm a project manager with FIATech, and I want to welcome you all today. I also manage the information management and automated design parts, the FIATech roadmap. On behalf of all of us at FIATech, I'd like to thank you for joining us today for the Asset Lifecycle Information Configuration Management and Deployment webinar. Today we have an exciting hour set aside to learn from Ted Weitzman about asset lifecycle information. But before we get started with the presentation, I'd first like to review how to use GoToWebinar system to optimize your experience today. So there's a control panel on your right side, and if you want to minimize that, you just click on the orange little arrow on the top, and then you can kind of move that around and put it to the side so you can see the full screen. We have quite a number of people on the webinar, so everybody's automatically muted because of all the participants. So if you do have a question, and we would certainly like questions, we'll save some time at the end for your questions. If you see in your control panel, there's a little part that says questions, and you can click on that and please type your question during the webinar, and we'll go through the questions at the end, and the questions will be read anonymously. And we are recording and posting this webinar, and so that will be available in the webinar archives on the FIATech website, fiatech.org. So lastly, and before I introduce today's speaker, I'd like to remind you that FIATech is a member-based organization that brings together companies to accelerate the development of technology in the capital projects industry. We have over 65 member companies and always looking for new ones to join our growing consortium. So if you are interested in joining and would like more information or ideas for future webinars, just drop me a note at faith@fiatech.org. And now I'd like to welcome and introduce Ted Weitzman. Ted has worked for Southern Company's engineering and construction services for 12 years. He has focused on project execution processes, configuration management, and automations to ensure efficient availability of information for CapEx projects and O&M. And since 2009, Ted has spearheaded the configuration and implementation of Southern Company's asset management database. And this project won Bentley's Software 2011 and 2012 Be Inspired Awards for innovation in asset lifecycle information. Thank you, and you're on, Ted.
Thank you, Faith, and I really appreciate the opportunity to be here today and to do this presentation around Southern Company's deployment of a software system to maintain asset lifecycle information management for cradle to grave through CapEx and OpEx operations for downstream consumption. I'm going to start today's presentation with a concept, and this helps me drive through the concepts around our strategy for information management. And basically, it's this. We have a tremendous amount of data that is produced within our organization. And the challenge is to take that data and normalize it, process it, turn it into information, contextualize that information to produce knowledge. And, of course, knowledge is where you drive value through your business. So that is the overarching framework behind our Asset Lifecycle Information Management program. Now, for us, knowledge was traditionally transferred and is still transferred through the deliverable of a drawing. In our environment, it's our design organization working in an in-process file management tool, which for us is the Bentley ProjectWise Explorer. And through that and through some automated workflows, we produce renditions and we transmit those documents into our document of record management system, Documentum. And then through that system, wider distribution is available. And of course, this is a controlled, managed process. Now, if we step into the Southern Company organization 7, 8 years ago, and you took a look at this process around data as opposed to documents, what you find is a much different environment where our design group splits into the 3 main disciplines that deal with rotating assets or equipment. And in our environment, our instrument and controls and our mechanical group use the Bentley Auto Plant tool to manage in-process design, both graphics and data. And our electrical group used a Cigna PDMS, which is basically for us a circuit routing tool in our environment. And both of these tools produce a great amount of information in the engineering group at the birth of the asset. But 6-7 years ago, distribution of information from those systems looked nothing like it did for documents. Basically, it was chaos. Downstream participants were aware that a tremendous amount of information, or actually data, I hesitate to call it information, but data was being produced or created in the design group, and individuals would go to individuals in the design organization for requests for data, but it was absolutely not controlled. Quality couldn't be ensured. Distribution was hectic. Once it left the design group and went downstream, the downstream participants communicated amongst themselves, changed the data, added information to the data. I mean, it was just sort of pell-mell and chaotic. There was no control anywhere near the way that we have control around documents around this process of distributing and consuming data. So our Executive Management Council made a decision to rectify this situation and wanted to deploy a system to normalize, qualify engineering data for downstream consumption in a model very similar to what we've been doing with documentation. So what we needed to do was take this data, which unfortunately doesn't always take this nice a form. If you can read binary code, you can interpret what that says. But unfortunately, data management feels more like this. Data itself is disparate, is usually non-normalized, and contextualizing it is a challenge. So we deployed a tool to help us rein in that chaos, at least within the engineering environment initially. And this is the meat of the presentation. There are 3 main qualities or principles which deploying any sort of engineering information management system requires. And I'm going to talk in detail about each one. One is data quality management. And this tool has a robust data quality manager. It's the EB Data Quality Manager. The Bentley EB Data Quality Manager is the tool that we chose. But I try not to focus too much on the tool. It's more about the qualities of a tool that you deploy. It's got to have a method for you to manage quality, a way for you to manage quality. It also has to allow you to manage change. And by management of change, I mean around the information that is accumulated around the asset object. You have to be able to take the object from cradle to grave and allow its information to change through the iterative processes that happen either through a project, the execution of a project, or the changes that are inevitable in the operations and maintenance environment. And the other thing is flexible architecture. And I will get into more detail about what flexible architecture means and what deploying a system like this entails within your environment. And I focus that around this concept of flexible architecture. So I'm going to talk first about data quality management. And this is the best I could come up with graphically to represent data quality management. It is not good enough just to accumulate data. You have to ensure or find a way to make sure that the data you're collecting is clean, is good, is quality, right? The person who made this slide for me kind of presented this as a joke when I said, please make something that represents data quality management. And I stepped away from my desk, came back, and to her chagrin, I've left it in the slide deck ever since. She kind of put it in there as a joke. But it's a good representation of what we're talking about. It's not just mining it. It's also putting it through some sort of cleaning process, scrubbing process. Now, one of the ways to do that, and there are many ways to do this, but here are some examples of how we maintain data quality. And there's an evolution here, a process of evolution here that I'm going to talk about in the way that we've deployed the system. All right, one concept is creating around data the same iterative design process that you put your documents through. We're all familiar with sort of revisions of documents and documents going through a design organization through an iterative process. You've got to put the same sort of control or concept around data in the environment, that it is part of your iterative design review, and putting in tools to allow that to happen. So when we configured and deployed the EB Data Quality Manager, our first concept was the formation or the creation of reports around the asset information that's coming into the design, into the EB Data Quality Manager from the in-process design tools. So one of the things that we can do with the system, and that we do with the system, is we take a tag, we put it through a series of quality review processes, and I can talk about those in detail maybe in the question and answer period, and then report on that. So what we can do is we can take a tag in and accept it like I did previously, or we can take a tag in and based on a certain set of analysis, reject it. But in that rejection, put it on a report to return back to the originating design discipline, saying at a very base level, your tagging structure is wrong on an asset. Which is one of the main reasons why an object would just completely fail a validation process. But another thing we can do is we can receive an object into the database and say, yeah, it's clean, it's good to a certain extent, but there are some issues, and the issues might be specific to a life cycle state, and I'll talk more about life cycle states in a minute. But for this life cycle state, this object is missing this information, or this information is, through analysis, incorrect. And again, the key is putting those in reports and returning them to the originating design discipline. Another thing we can do, and this is just as critical as the other ones, is report change. And why this is critical for us in a project execution process is especially in that last 10% of push for the project where change can happen, but communication becomes always encouraged, but can be lost sight of the hectic environment of the last stages of project execution, where we use the EB Data Quality Manager to help with the communication of design change. An example could be here that a pump requirement at a particular location has changed and the size has increased. But at this point in the design process, a cable has already been designed, a circuit for the motor that's going to drive that pump has already been designed, and the cable was designed to the smaller motor size to drive that smaller pump. And what we do is we can report change that, hey, electrical group, a change has been made to this particular location that was going to require a reanalysis of the circuit at that location. Now, what we relied on in the past was verbal communication, pick up the phone and call them, and that should always happen. But if that did not happen, and unfortunately there are cases where it doesn't happen, you rely on the expertise on the site to ensure that the small cable, the smaller size cable doesn't hook up to a larger size motor, which is either going to cause damage to the motor and or the cable and or both, and you hope not cause personal injury to anybody on site. So again, reporting that change through this process ensures quality, but on a higher level. You might have had a quality design based on the previous design criteria, but the design criteria has changed. How are you going to ensure that that communication is happening within your design department? And we use this system to do that for us. All right, so those were some of the basic tools we put in place around drawing and data management. We already had the drawing part in place, but then we successfully deployed this part around data. And I want to talk a little bit about that deployment because this is part of our story. We started development of this data warehouse, this data quality warehouse in 2006. In 2007, we went into a deployment mode that became a proof of concept. Again, that was in 2007, and we worked very hard on working with our vendor, Bentley, and in configuring this tool to support our current design processes and standards. And towards the end of 2007, we made a determination internally that this was not working. It had nothing to do with the technology or the employment or the engagement with the vendor, but that there was something wrong internally with our processes and standards. Because what we developed was a tool that supported the current process and standard, but whenever we went to go push data through the tool, the data itself was failing. And we had selected a pilot project, and we had even told the pilot project teams that data quality management was going to be a part of this project and that they needed to ensure that they were following the processes and standards, the procedures and standards, because we were going to be qualifying the data against it. And so the first reports that we came back that were showing failed validation on tags, we went back to the design teams and said, hey, all these tags are failing. Why? We thought you were using the standard. And they would say, well, we did use the standard. And when we come back with specific reasons of why most of the tags were failing, they would say, oh, yeah, no, we couldn't follow the standard for those tags. And determined very quickly that we had some issues internally with our standards and our procedures. And we were able to talk with our upper-level management, convince them that there wasn't a technology problem here, but that we needed to prepare our design organization for data quality management and do a very thorough review of our current processes, practices, and standards. So we put the data quality manager on the shelf. And for 2 years, we did a in-house revamp of our processes, our procedures, and our standards, and also prepped our culture for data quality management, true data quality management as it relates to our designs. And in 2009, thought we had made enough headway to pull the product back off the shelf and start another process of deployment. And it took another 2 years of, again, working on the actual development of the tool, and I'll talk more about that later, and also more preparation for the environment, more work on the standards and procedures to actually deploy the tool, which we did in April of 2011. But we deployed with this model where we talked a lot about drawings being a deliverable and separately data being a deliverable. And that's sort of the environment that we went into production with in April of 2011, knowing that this was not the right model moving forward, but it was an intermediary step to the ultimate goal, which is this: an integrated process where your deliverable isn't specific to a drawing or specific to data. It is specific to a design. It's a design-centric environment as opposed to a drawing or a data-centric environment. And one of the things we needed to do was find a way to integrate drawings and data in an iterative review process. And another element here also that I don't talk about is, of course, the 3D model as part of your design deliverable. But that's for another discussion. So what we did, starting, again, this was last year, so we've been in production for 6, 7, 8 months doing data quality review. We started wholesale work on an integrated process where we can do drawing and data review simultaneous in an iterative design process. And so the way that this works for us is that we have a true integrative environment where we're using the Bentley AutoPlant tool, the Bentley ProjectWise Explorer tool, the EB Data Quality Manager, and Documentum workflows to integrate a review process for design. And here's kind of the way it works. The design organization inputs into the in-process design tools, right? And we go through that process of data quality review as the graphics are built in specific CAD tools to create drawings. But what we built into the ProjectWise Explorer tool is an ability for a designer engineer to select a drawing and produce on the fly a report that compares the EB Data Quality Manager qualified data as it relates to assets on that specific drawing to the in-process design data that's in the in-process design tool, and produce a report that shows the state of the assets that reside, the state of the data behind the assets that reside on that drawing, and gives that designer engineer information so that they can update either the graphics and or the data as it relates to the assets on a drawing. And again, going through this iterative review process prior to producing a package of drawings for actual transmittal. What we've also produced in the ProjectWise Explorer tool is a mechanism where a designer engineer can create a package of drawings. And typically, in previous processes, this package of drawings would go straight to a reviewer for approval. Well, it takes a pit stop now on the way to the approver. It stops basically at the EB Data Quality Manager where a asset health report is produced for the approver to review. And for us, in our environment, we're really looking for a report that is blank, there's nothing on the report. Because this report will break down by drawing and show any asset health problems for any drawing. It'll show all the assets on a drawing that have reportable issues with the data behind the asset. And what the reviewer can do now is either based on the graphical content or on the data content that's represented in the report, they can either approve or reject the drawing. Of course, if they reject the drawings or the package with the report, it goes back to the design organization for graphical content update, or again, data revisions or updates. And then, of course, the package can be recreated after those corrections or revisions are made, go back to the approver, or actually stop, of course, to get the report at the EB Data Quality Manager, and then go back to the approver for review, where, again, you're looking for an approved package. The data quality health is ensured in the EB Data Quality Manager, and, of course, the renditions and the drawing revisions are made available for distribution through the document management system. Now, there is some effort required to make all of this happen. We can talk about that also in the question and answer period about what kind of impact does this truly have on, say, an engineering environment. But why? Why would we want to go through this process in our environment? And for us, the lowest hanging fruit had to do with the way that assets were related to documents of record in the document management system. And I've talked to a lot of folks who have document management systems, and they have very similar issues to what we had in Sight. We had excellent processes around document management. We had an excellent management system in Documentum, but we had a search mechanism that, to no fault of our document management tool, was inadequate and relied a lot on experience and specific facility information. Because if we had an operations and maintenance person sitting at an asset, typically there would be a nameplate on that asset that had that number, the asset identifier. In this case, we're looking at a motor 6070. What the operations and maintenance person really wanted to do was have the ability to plug that number into a system to produce a set of documents. But the reality was that the only thing that you could do in the document management system, and still to this day do, is do a keyword or title search, which very rarely has asset numbers in them. So what they had to do, based on experience and knowledge of the system they're working on and the piece of equipment they're staring at, dream up a keyword or a title search to throw into Documentum, which then produced a list of drawings. And this is what was dependent on your experience using the system, and your experience with the facility is really what kind of keyword search you could come up with and how small a set of documents you could produce to review to find the document that you're looking for. Now, these kind of searches take time, and at a very low ball estimate for the people that are looking for documents, you know, I've heard numbers ranging from 15 to 60% of any individual's time annually performing these kinds of searches. And for us, it was managing the engineering data. We should be able to eliminate this process and that 15 to 60% of an individual's time trying to find information as it relates to an asset. So what we successfully deployed with the EB Data Quality Manager was the ability for anyone, either in operations and maintenance or anywhere else in our organization, to take the asset number, type it into a system, plug it into a system, and produce the document set for that asset. And not only that, you will produce from this system all the related objects. So if you're looking at a motor, you will immediately have access to the pump that it drives, the circuit information, the process line information as it relates to the pump, and really drill through the entire facility through these relationships. And on top of that, from the system, you're also going to derive all of the data behind each of those objects, each of the assets, including any data behind the document itself, because there's metadata, as we know, behind the documents as well. So not only are we eliminating that 15 to quote-unquote 60% of a person's time searching for documentation as it relates to assets, we're also producing quality information that is valuable beyond the document set itself in terms of the ontology, the relationships between any object to another one, and also the data that we're able to produce. And the return on investment here is pretty large by eliminating that 15 15 to 60% of a person's time. 15% of the average employee's time in our environment annually is $30,000. We have over 100 units in our system that employ literally thousands of people, and that's just for operations and maintenance. Within our engineering construction services group, we are over 1,500 people strong. A majority of those folks are also doing these kinds of searches. And if we can eliminate this sort of clerical work and trying to just locate documents in our organizations, that 15%, that $30,000 annually per employee adds up real quick. But another way that I like to do the return on investment here is per location at a facility. And let's say at a location, let's take a 10-year operating period, and let's say that this ability over that 10 years saves 2 hours, just 2 hours at that asset location over a 10-year period. 2 hours is basically equivalent to $200. If we can save $200 per location every 10 years and then multiply that across all of our locations, the numbers add up into hundreds of millions over 20-year life cycles very quickly. And I'll let you guys kind of do the math, or I can talk about that again more in the question and answer period. But this was huge, low-hanging fruit for us. And it hinges around data quality management. It's one thing to be able to produce a system that does this. It's another thing to produce a system that does this, and you can ensure that the quality of the information produced is near 100%, because that's where it has to be. It has to be near 100%, because at 3 a.m., when your operations person has an emergency at a location, and you've told them that they've had the ability to type in that location and produce the information that they are looking for, the problem is if they type it in at 3 a.m. and they don't produce it, they're going to throw the entire system out the window and go back to what they know, which typically means drawings or information in their lunchbox. All right. From data quality management, I want to talk about management of change around the asset information that you're collecting. And you have to have a system that allows you to manage the asset from cradle to grave. And in our case, that means being able to carry the asset through a conceptual lifecycle state, release that information for detailed design and allow it to change, take it to a supply chain activity like releasing it for procurement, releasing that information to site for construction, and then eventually handing that over to operations and maintenance as an as-built set of data, very similar to what you would do for drawings as-built drawings. And of course, you also have to have in the system the ability to take that design data, any of that asset information as it relates to that location, back through the process for retrofitting or design change. And then, of course, able to decommission either single locations or entire facilities. And I'm going to talk about some of the challenges around doing this, and some of these are the traditional challenges of handover from, let's say, EPCs to operators, owners, maintainers. We are in a very unique position, really, within the power industry, certainly within the United States, but also sort of in the facilities industry as a whole, where we have a robust EPC internal to Southern Company, and we call this group our Engineering Construction Services Group. This is kind of important to keep in mind as I go through some of the detail here, that we have an EPC internal to our organization, and it's a pretty robust organization. One of the problems historic with handover is dealing with an external party, whether it's an EPC, a vendor, a manufacturer, whoever it is that is going to be providing information as it relates to assets or systems to the operator or maintainer. And a typical scenario is collection of information by that external party. Who knows what it is? It could be drawings, could be data, could be both. Who knows what ends up in this bucket of information that is usually handed over to the facility or the operator or owner as a complete commissioned system. And it's up to the owner-operator to muddle through that bucket of stuff to extrapolate what is pertinent to operations and maintenance in that environment, and usually to, again, renormalize it for whatever systems are requisite for that facility. Now, what we've done with Southern Company is we are leveraging our internal design organization, which is about 500, it's over 500 people strong, and we have many projects, both capital and operational, that our design organization manages. And what we are able to do is leverage that design organization as a recipient, as a procedurally required recipient of information from that external party. And we receive information as early as we can in the design process. And instead of creating a bucket of information that is handed over at commissioning as built to a facility, we manage a pool of data in the EB Data Quality Manager through a design execution process, and our goal is seamless handover to our facilities. An important thing to note here is that as the information is received from that external party and put into the EB Data Quality pool of information, that external party information goes through the same rigorous data quality control review as an internal design would, as if it was authored in our own design tools. And that's very important. So this has big benefits for downstream participants, not even going all the way downstream to operations and maintenance, but for our startup commissioning group, for our construction group, even for our supply chain. And I'm going to talk more specifically, I'm going to give some examples around our startup commissioning group and how they're benefiting from this model of external party handling of data. But I want to talk about another thing, too, that is important for the handover process, and it has to do with the languages that we speak around asset development. And in our environment, the gospel is a functional tag. And our design organization is very good at creating functional tags and at this point managing data as it relates to those functional tags through a project execution process, which includes taking that asset tag and handing it over to operations and maintenance. The problem is that even internal to our environment, the language that we talk around the asset through the project execution process is not the same language that will be used around that asset in the operations and maintenance environment as it specifically relates to the tag, the functional location. We, in the project execution process, see the tag as strictly a functional location, where in operations and maintenance, they have to marry that tag to some sort of hierarchy that usually relates to a system of accounts. And traditionally, relating that functional tag asset to the hierarchy as it relates to the classification of accounts is something that happens at that quote-unquote handover, at the as-built process. The problem with this is that on a very large project, this can become overwhelming to the maintainers of the asset at the site. So we're doing proactively right now are engaging our system owners at our facilities to help us, or for us to help them and for them to help us manage the functional tag and the creation of that accounting hierarchy much earlier in the process, so that these assets in these hierarchy locations can be quote-unquote handed over much earlier in the project execution process, so that it isn't an overwhelming task by the time it gets to the facility as an as-built or post-commissioning. And again, this is something we are proactively doing. It's a task that I thought looked like crossing the Grand Canyon by foot or with very few tools. But the reality is that it's more like the Mississippi River, and we have to build a raft, and we're going to row the raft together, as in the project executors and the system owners. And but we're going to come to a solution that, through the data, through managing the data, produces a feasible handover of the asset as it relates to the operational hierarchy much earlier, again, much earlier in the design process. And it's something, again, I'd be very happy to talk about in the question and answer period. Now I want to talk a little bit about flexible architecture. And this is where you're tasked with building, in essence, a reference data library for your environment as it relates to the assets that you're going to manage. And it has to be flexible because this is not a project with an end. This reference data library, this set of standards and procedures that allow you to manage data in the reference data library is not something that ever becomes static. You would adopt new technologies. You have to create new assets as they relate to those technologies. You are going to, if you're a pure owner-operator, you're going to acquire facilities that may require you to tweak the reference data library to receive that set of assets coming from that new facility asset that you hadn't maybe had in your organization previously. But more important than almost all of that is that you're going to be improving your processes and your standards as its own iterative process, and you need to be able to maintain and manage that internally within your environment. And here's an example of a simplified version of a reference data library that includes some assets, where you've got a process line object, which is a sort of a system-level object, but to me is absolutely an asset because you maintain engineering information around it, and people need that data, need that information to perform certain work functions. So even though that's a conceptual object, it is an asset in my eyes. That process line relates to both a pump and a motor as it sits in a system. The motor is going to be connected to a circuit. The circuit's going to be connected, in this case, probably to a motor control center. And we've got a small working system placed in a reference data library structure with all of the ontology, which is the relationships behind those objects, and of course the taxonomy, all the definitions behind the actual objects themselves. Now, this is a challenging process to develop. All of the assets that you're going to manage in-house with their taxonomy and the way that they relate to one another. This is part of that 4-year process of putting the product on the shelf and working on our processes or standards or guidelines. A lot of it had to do with the definitions in our reference data library. How do the objects relate? What are the objects we need to related to each other? What are the definitions behind those objects? But once you have this in place, along with your data quality management and with your management of change, you're really able to leverage the information that sits in your reference data library. And this is where I'm going to talk specifically about our startup and commissioning group and the way that as a downstream recipient of this engineering information, they've been able to drive efficiencies into their organization and save money. So what's happened at this point is that information is being made available, asset information, complete asset lists as they relate to projects and systems. Is made available now through this data management system and is used by the startup commissioning group in their quote-unquote package builder, which is an internal tool that they use to manage their sequences around systems for commissioning. Now, there's still some manual work involved here where they will do P&ID review and make assignments to equipment based on the P&ID reviews and the system areas that they create on those P&ID reviews. But the advantage is that they don't have to assign codes to everything. They just have to assign codes to specific equipment types because of the relationships apparent in the system, where we can automate assignments to process lines. We can automate assignments to, based on the ontology, based on the relationships. Let's say you can assign the pump, and then we know that the pump, through data relationships, is associated to the motor, and we can automate the assignment of the motor. And what's even more interesting is when you get down to the cable level, where you know there's going to be system breaks, where the motor control center is going to sit in a different commissioning system than the actual motor itself that sits out on the field. And based on some logic, we can go ahead and automate the assignment of that cable based on certain information present in the reference data library. And of course, all of these assignments can be absorbed back in and added to the greater pool of asset information in the data management system, and then of course communicated to any recipient that requires the cable or the associations to turnover system requirements. In this case, in our environment, we use those system code assignments in the Cigna PDMS tool for communication to construction about circuit pulling and circuit termination as they relate to a startup system. So again, we're sort of adding to the pool of data and controlling the way that information is passed through organizations, which is, if you go back to one of the very first slides, was one of the problems that we had. There was absolutely no control over the way that the data was exchanged between organizations, and we use this tool to do that. And now I'm going to talk about why. we had to go into deployment for this project, which is currently being built in Mississippi. This is the Plant Ratcliffe Integrated Gasification Combined Cycle. This is 21st century clean coal. We are taking a lignite coal, which is, for all intents and purposes, combustible dirt, and we are taking this traditionally dirty coal and gasifying it in a gasifying unit, turning it into a syngas, which is then scrubbed and cleaned and then burnt in a combined cycle with 65% carbon capture, 99% particulate capture. Again, when we talk about clean coal, this is the type of technology we want deployed in this, well, really this decade, even this century. Again, this plant is scheduled to go live next year, and it's currently under construction, and it is a huge project for us. Nearly $3 billion, and I'm going to talk about the asset count right now. We went live for this project in April of 2011. By November of 2011, we had collected 106,000 assets. So they're called objects here, and that's because some people don't like to consider documents assets, but they are 100% an asset in my mind. We have physical objects, which are actually mined physical objects from a model. Tagged items would include circuits, motors, pumps, instruments, instrumentation, anything that's sort of a functional location. And then, of course, separately, we have process lines and pipe runs, which are again, that process information as it usually relates to a P&ID. Again, these were the numbers as of November of 2011. Jump to November of 2012. We have nearly 237,000 assets managed for the project, and I didn't have a chance to update this just to reflect the numbers as of today, but this number is right around 300,000 assets being managed for the project today, which is huge for us. We were used to managing very large project, combined cycle projects, environmental projects for our coal fire facilities. We manage a lot of those internally, and we're used to dealing with large-scale projects. But this project in particular, let's just take an example of the startup and commissioning group. Sort of record number of turnover packages or startup sequence packages for a large project for us is somewhere around 400 or 500 packages. This project has double that already, around 1,000 startup packages to check out and commission for this facility. And it's a tremendous amount of information to manage, and we knew that we needed to do a better job managing the information for this project than we had on previous projects, just to drive efficiencies and to meet schedule and to meet budget. And I want to talk about this process that I sort of articulated earlier about automating part of the startup and commissioning process in relationship to assigning assets, providing complete asset lists, and automating the process of assigning those assets to packages. Around the startup commissioning process for this plant, we have about 45 people over a 2-year period working on commissioning processes. That comes out to about 187,000 man-hours around commissioning activities. And I'm going to break that down to minutes. That might seem a little bit ludicrous, but it's all going to make sense in a second. That comes out to about 11.2 million minutes. Okay? That comes out if you consider the fact that they're going to touch about 150,000 of those 300,000 assets, right? To them, 150,000 of those objects are important and will need to be associated to packages. That averages out to about 75 minutes per asset, okay? If through this process, and this was our goal, if through this process we could knock that down to 60 minutes per asset, saving 15 minutes per asset location, that's about a 20% savings. That saves approximately 37,000 man-hours over that 2-year period, or approximately $3.75 million. Now, in context of the overall project, that's a very small percentage. But in the context of the budget and the schedule for that particular group, that's huge. And any amount of efficiencies that can be driven through data management into a project, it's phenomenal the amount of impact it will have on any particular organization. In our case, too, this process affects our electrical group, where in the past the electrical group became responsible for assigning the circuits to turnover code packages. And the problem is that the sequencing was given to them in the form of PNIDs. Circuits do not appear on PNIDs. Instrumentation and equipment that requires cabling appears on a PNID. So they would have to extrapolate from a physical drawing that's in their hand. They'd have to look at the equipment and then find the associated circuit and then assign the package to it. And let's just say this took 6 minutes per circuit. Okay? To us, that 6 minutes costs about $10, right? We have over 25,000 circuits on this job. If it was just 25,000 circuits, automating that process of assignment would save the electrical group specifically approximately $250,000. And we have automated that process. And for the 29,000 some odd circuits, the assignment process is much more efficient than it was in previous projects. And those are just some very specific examples of how you can drive efficiency through data quality management into a project execution process. And again, that trickles all the way downstream into operations and maintenance, where the ultimate goal is a seamless handover. Now, to further the good news, we started in fall deploying this technology on brownfield projects. We are deployed on an FGD scrubber, a flue gas desulfurizer scrubber project, also in Mississippi. We also went into projects around backhouses or mass requirements projects in mercury control, which includes backhouses, active carbon injection, and some other technologies to reduce mercury emissions at existing coal-fired facilities. And we are currently in production for 4 of these projects, with more to come over the next year. We are managing approximately, if you include the other information that we've incorporated into the system for these brownfield projects, which we went ahead and acquired and accumulated in the data quality management tool, all of the existing asset information that was available through the engineering group, we were managing somewhere right around 1 million assets for these existing facilities and for the Kemper County Plant Ratcliffe facility that should go live next year, which is a huge accomplishment for us internally. It was always our goal, and the ultimate goal is to deploy this system on every active project within Southern Company. And with that, I'm going to say thank you. I think I went a couple minutes over my 45-minute time slot, and I think it was a tremendous amount of information. I hope you've enjoyed it. Of course, I am very honored to represent the work that we've done internally, but it is certainly not the work of a single individual. It's the work of a team of folks, and here are just a few of them, both internal to Southern Company and with our software partner, Bentley, that have helped in the deployment of this technology at Southern Company. And with that, I'll hand it over to some questions. Thank you, Faith.
Thank you, Ted. That was excellent. And if you've got some questions still hanging out there, please send them in. So we do have some to go over. And yeah, Ted, I can see why people really enjoy hearing your presentations, because I think besides talking about the technology side, you address the culture, work processes, and business case, which are you know, maybe some folks even think the more critical elements of deploying an asset lifecycle information system. So thank you. That was excellent. So the first question is, how did Southern Company get external parties to comply with forming of data to be absorbed? And what level of compliance do you see? Sorry.
No. That's a great. Both those questions are wonderful questions, and there's a best case scenario, right, where we have an external partner who has agreed to use our configuration of our authoring tools. So we have a EPC right now that is using our configuration of AutoPlant to do their design. And again, it goes through the same quality management process as our internal design. Now, that's a best case scenario, and that's a partner that we've worked with for many years on specific technologies, and we've got a great working relationship, and it was easy to build that into the contractual negotiations when negotiating the requirements for that project, where it becomes right there with your drawing deliverables that are usually specified in a contractual negotiation. It's also negotiated and required that you provide data in this format. Now, again, best case scenario. Sort of a middle case scenario is where a partner is not going to use your design tools to your configuration, but we specify in a template that this information will be provided in this format for absorption into our organization, and very similar to the way that you would set up a schedule for receiving drawings, like IFC drawings issued for construction drawings. You would specify along with that drawing requirement that the asset information is also provided at those milestones within the project. A worst case scenario, of course, is working with a partner where nothing is going to be provided, and they will not contractually agree to the provision of any data. And this is where, in all these cases, Southern Company has, and I'm going to call it a luxury, the luxury of leaning on its design organization. And what we've procedurally required is that regardless of the contract with any external partner, the design organization is ultimately responsible for the data as it relates to assets for the project. So if we are in a scenario where the asset information is not going to be provided by the external partner, the onus is on our design organization to create that information in our internal authoring tools. Again, that's something very specific to Southern Company, and I'm going to say that the design organization didn't necessarily stand up and volunteer for that role, and that's where your management support comes in. You know, that required management approval and inclusion in the procedures to really drive that into the organization.
Okay,
I think that covers.
Yeah, no, that was excellent. You got the three scenarios covered. That was great, and that you actually led into the next question. I think, was it difficult to get management support, especially at the beginning when going back to review basic processes?
Yeah, surprisingly, no, and that's where I have to give a tremendous amount of credit to the sponsorship behind this project. You know, the first challenge was really convincing management that there wasn't a technology issue at that time, 2007. It would have been, and for some was very easy to point at this technology as a failure, right? There's a problem with the tool, especially when you're basically supporting an IT project that fails. Too often it's easy for a business unit to point at the tool and say, well, there's a problem with the tool, our processes are fine because we execute our projects really well. And I want to say that Southern Company has always executed its projects very well. Excellent, industry standard, I mean, very well. And so it would have been very easy to kind of point at the technology and put it on the shelf and let it die there. But the first real big kudos to the management was the recognition that, yes, this is something that we need to do within our organization, and it is not a tools or technology problem. It has more to do with our business processes, and really putting it on the shelf and going to work on the business processes. The second big challenge for me personally was in 2009, and again, I'm going to give credit to the Management Council that listened to this and supported it. I was working in electrical retrofits group, really all of the electrical group at that time, working on processes and procedures, but very specifically to the electrical organization, when I was tapped on the shoulder to do this deployment, to take it back off the shelf and manage the project around configuration and deployment of this data quality tool. And somebody went to my boss and said, we'll need Ted for 2 years, 50% of his time. And when they finally tapped on my shoulder, that's what was agreed upon. And I had a decision to make, a yes or no, will I do this? And I really wanted to do it, but with clear communication to executive management that this is not a 50% job, 50% of an individual's time, nor is it a project with a terminus. This is something you have to commit to for the long term. And I built up a business case where the return on investment was clearly built around the document searching as it relates to assets, which again has a return ROI over decades, right? So there's where your value is in committing the resources 100% to this project for an indefinite period of time. And that was really, in my eyes, the second major milestone that we overcame with management support, was in them hearing that case and approving it to dedicate the resources to this project and to not put it around a project mentality where it has an end.
That sounds like job security, a good approach for that, Ted.
It goes back and forth.
So let's see, the next question was, is your process similar to IPD, which I think is Integrated Project Delivery is what they're referring to? That's what the building information modeling folks use. Are you familiar with that term?
It's a term I'm familiar with. It's not a process that I'm very knowledgeable on. And I would encourage whoever asked that question to contact me offline, and we can have a little bit of dialogue about that process
Okay.
and do some determination, because I don't have the knowledge to answer that right now.
Okay, and since we've got a few other questions and then not much time, can you describe again the accounts applied to asset location, and are they related to cost, maintenance, or what?
Yeah, cost maintenance, and I'll go back to that slide real quick. So this is something that we did a Maximo deployment very recently for work maintenance orders, right? And we both sort of, in 2009, 2008, that team was getting its requirements together, the Maximo deployment team, where they were going to go heavy into configuration. And then, of course, around the same time, we were dealing with this system, and we knew they were going to need to be integrated. But the thing is, we talked very early on, and then we separated. And we separated and went into our own little development worlds, thinking we had an understanding of our relationship to one another, right? But we both came out of our boxes around 2011, and I realized very quickly that we had huge gaps still remaining around this hierarchy location structure and what has followed through the project execution process and the functional location. And the simple answer to the question is yes. What I'm showing here in that KD-AAAA structure is the work maintenance structure related to accounts for when you write a work maintenance order on that asset, how it's going to be accountable or charged through the accounting structure, right? And the goal here is to get us closer to speaking the same language, because what I realized is that this functional location as it relates to the hierarchy is not something that the folks in the design organization are familiar with. It's something very specific to that operations and maintenance environment, and really is a symbol of how we speak different languages around the same object. And data management and trying to manage this as data has really brought this problem to a light within our organization, and we know that we can drive efficiencies by managing this information better. This is one of those places where we had a gap and we were losing money because we weren't efficient in the way that we managed this classification of account structure and the functional location.
Okay, no, thank you, Ted. And actually, I'll just say the FIATech HEED project has been struggling with that life cycle data management through the phases and how the information changes. Okay, so the next. Go ahead.
I'm just going to follow on to that, and what I will say, the key for us here, and there are many ways you can solve these problems, just for us, across systems, what we've decided as our sort of our keystone is the functional location number. As long as we can maintain that functional location number across our disparate systems, right, and that neural network, that's where the connectivity is, then we can build processes around that. But the key is that functional tag, but also finding ways within the process to help build that classification of accounts hierarchy around that, the same way that you would build engineering information around the asset.
No, excellent. Thank you. Okay, another question. Did you develop your own RDL, your reference data library, or use other existing standards like ISO 15926?
Very good question, and I applaud and support the ISO 15926 and other standards efforts, but Southern Company is very unlikely to adopt those. So we have an internal standard that we've created and maintained. And of course, we have a vested interest in the success of those external standards, because it will make our jobs a lot easier when interfacing with external partners.
Okay, thank you. So next question. Information management is a new discipline. Who does it report to, and is it part of engineering?
Yeah, good question. We have just recently formed a design automation team, which has its own reporting structure. In the past, I have always reported through the engineering group, specifically through electrical, and other individuals supporting these types of efforts, even in support of the design automation tools, have sat in disciplines within the engineering group. It was a huge success last year when we formed this design automation team, which I now sit in and report through its structure, but still very much in the engineering environment, with a recognition that this project has had to sit in engineering because it for us in getting traction, it is where the asset takes birth, where it takes shape. The long-term goal, I think, is to make sure that things are solid and working properly all the way upstream here in engineering, and then start popping probably this particular software and functionality outside of engineering and start really plugging it in where it has more oversight or line of sight for the entire process. But I will say that the support in the engineering group has been essential and good because, again, this is where the assets takes form and starts developing its information, but also the interaction with the downstream recipients has been, that line of sight has been very clear and the communication very good because the value is being seen and reaped.
Okay, no, thanks, Ted. And we're getting near the end of our hour, but we have like one comment and one question, so if people can hang on for just a couple more minutes. So somebody's comment is they'd like to speak with you offline on how you are integrating this into your Maximo deployment, and maybe that's a topic for another webinar.
Yeah, I'd love to. That kind of goes into that CapEx, OpEx. Yeah.
Yeah, and so then the last question is Southern also using other Bentley tools such as Construction Sim for work packaging installation work?
No, we're not currently using ConstructSim. Matter of fact, I consider that the construction realm a materials management sort of issue. If I'd wrap a concept around it, it's around materials management on site. And we are exploring that in the ways that our data management practices can, again, drive efficiencies in the way that we're managing materials on site. But as of right now, we have project execution processes that support project solutions to materials management. And I think what you'll see coming out of Southern Company very soon is an effort to standardize across projects the tools that we're using on site around materials management. And they may or may not be homegrown. I'm not sure if they'll be vendor supported yet or not. We have a very robust internal IT organization as well that helps us with a lot of these solutions. So no Bentley products that I know of around materials management right now for construction, but construction is definitely something that I've seen and have expressed interest in. But again, it's sort of a downstream goal of ours is to drive efficiencies in that process.
Excellent. Thank you so much, Ted. We've come to the end of our hour, unfortunately. And I just want to remind everyone that there is a recording that will be made available in a few days on the FIATech website. Thank you again. And our next webinar is on May 7th on U.S. local codes in the cloud. Excuse me. Thanks, everyone, and have a great day. Bye-bye.
All right. Thank you.
Thanks, Ted.
All right.
Bye.
Bye-bye.